Hello guys, today we will see the Leetcode problem number 1292, which is the maximum side length of a square with sum less than or equal to threshold. Let's see what the problem says to us. Given the m by n matrix MAT and an integer threshold, return the maximum side length of a square with the sum less than or equal to threshold, or return 0 if there is no such square present. So we have to return the maximum side length of a square. Okay, so the side of a square we have to return which is having the square which is having the sum of all the elements is less than or equal to the threshold. Okay, the threshold is also given to us. Threshold here it is given to 4, and that sum of that particular square which can be found inside the matrix only, that sum of all the number of elements which are present in that square should be less than or equal to the threshold. Okay, and we have to find out the maximum square length. Okay, maximum square side. Okay, so for this we can get to know that we will have to traverse for all the size of the square, from larger to smaller or smaller to larger. We can traverse from all of them. So we will need nearly n cube time complexity for this. Okay, because we will traverse for n square numbers for n side of that square. Means we will travel on each cell. So for each cell we will get the time complexity for n square. Okay, for each cell. Okay, let's clear it. Okay, for each cell we will need the time complexity of n square for each cell. Okay, and after that we will need for every n size of the square, we will need for every n square cells. So that's why we will need n. Okay, n time complexity. So now it will total will give n cube. So n can be the max from the row and column. Okay, n is equal to the max from row and column. So this will be the time complexity. Okay, and the n cube, so we are needing the n cube time complexity. Okay, n cube time complexity we are needed, and the constants are m and n are 300. So in this way the 3 into 10 to the power 2, so we can make it cube, and we will get now 27 into 10 to the power 6. So it will last for 2 into 10 to the power 27 into 10 to the power 6. So it can easily pass, and mota moti we can say that 2 into 10 to the power, or 1 into 10 to the power, okay, 2 into 10 to the power 7 we can say, or 8 we can say, oh sorry, 7 only, 7. Okay, so in this way this will be passed. Okay, this time complexity can be accepted. Okay, now in this, how we will do the prefix? Okay, so we will consider, okay, so by using this example we can already conclude that we have to apply the prefix here. Okay, because it has given that we have to find out the threshold for every square, okay, which is present there. So for every square we needed the sum. Okay, the sum, the prefix sum we will do will be the approach we will do now will be the sum from left to right. Okay, the sum from left to right and sum from left to right after doing sum from left to right, we will get 1, 2 and 5. Okay, 1, 2, 5, 7 and so on. Okay, after that 1, 2, 5, 7 and so on, 1, 2, 5, 7, because this row and this row both are all are same, so that's why 1 to 5 we have got as a prefix sum for all rows. And after that we will make the prefix sum for all the columns. So in this way we will get the prefix sum for whole the matrix. We will get the prefix sum for whole matrix. So in this, now after this we can get, okay, I will write here. So in this way 1, 2 and 3, then 2, 4 and 6, then 5, 10 and 15, so and 7, 14 and 21 and so on, we will make the prefix sum. Okay, now for this array, now how we will figure out if we want, okay, this is the prefix we have got now. Okay, we have made this prefix. In this way we will make the prefix. If you have solved the various problems on prefix, so you will get this approach or intuition, and if you haven't solved any of the prefix problems, so you will get some of the complications, but you can okay, you can understand by this explanation. Okay, let's take, now we need this area, okay, the sum of this area. So this is the square, 2 by 2 square, and we need this area. Now let's say this 15, what the 15 is storing, the 15 is storing the sum of this whole area, and the 4 is storing the sum of this area. Okay, and 1 is storing, okay, sorry, not the 1, the 5 is storing this whole area, the whole sum of that all the numbers which are present in that region, and 3 is storing the sum of all the numbers, which are stored in this region. Okay, I will make it some different. Okay, so this whole all the numbers which are present in that area, its sum is present in this 3. Okay, this is the 3. Okay, so this whole prefix makes us found that, I will make it undo. Okay, yes, now we need this area. Okay, this area we needed. Now to get this, 5 is storing this much of the area, 3 is storing this much of the area. Okay, the sum of all of them. Okay, and after this, to get only this area, the sum of this area, so now the 15 is currently storing the sum of this whole area. Now minus what we have to negate, okay, how much numbers we have to negate, so this much of the numbers we have to negate, so 3 will be negated. Then 5 we will have to neglect, so 5 is also neglected. But now just okay, observe this, that 1 is taken 2 times, so 1 has neglected 2 times, but we only have to neglect it only 1 time, so that's why we will add this number. Okay, we will add this number which is 1. Okay, 1. In this way we will need 15 minus of 3 and 8. Okay, this will be 8. Okay, the how much of them we have to neglect is this is the 8 and this will be the 7. The 7 we have to neglect from them. Okay, so we will get the 8 as our answer. Okay, this is the 8, and in this region our whole, okay, yes, in this region just calculate by counting. This is 3, 3, 6, 1 and 2 means 7 and 8. Okay, so this is the only answer we have got. Okay, so for this method we have to do for all the squares which are present, which can be possible to make. Okay, and we have to calculate the sum of all the numbers which are present in that square. So this is the 8, which is the sum of all the numbers which are present in that square. Okay, now 8 is not less than or equal to threshold, so that's why it cannot change it. Okay, if for any of the square we got less than or equal to threshold, means the sum is less than equal to the threshold, so our answer will get changed. Okay, answer will be equal to the side of the square. Okay, side of the square we can say side of square. Okay, side of the square. Let's see the code, what we have done in the code. So we have initialized a prefix array, prefix vector, which is 2 by 2 vector, and we are making its prefix sum, storing its prefix sum into the 1D array, into the one indexed array. Okay, one based indexing array. Now after this, after storing the in this double for loop, so we are storing the prefix. Okay, only prefix, while this will go from rows. Okay, so the same we have discussed earlier in the video, we will store it in the form of rows, all the prefix rows. Okay, the sum of all the rows, and after that we will do the sum of all the columns. We can make it reversible also, that first we can make it the sum of all the columns, and after that we can do the sum of all the rows, the prefix sum of all the rows. So we can do any of them. It can be on the first, it can be on the second, or it can be reversible also, means we can interchange them. Okay, we can interchange them, and this will also is here. Okay, so that can be possible. Okay, now in this double for loop, okay, in this for loop we have now given, okay, now we have applied that n cube here. Okay, n cube means for every s, so you can apply here for every, okay, minimum from this will be the size, the maximum size we can go, and if we have got any of the size which is satisfying sum is less than equal to the threshold, so we can return it. Okay, we can return it, and for calculating the sum for every of the cell, and for every size which can be possible, for every size, for every square size, we can go for every cell, and for every cell we will calculate our sum for the prefix by using our formula, which will be the prefix of that prefix of ij, means on that cell we are going, and the prefix of okay, this prefix of ij minus of the prefix of I or j minus of s, means this prefix of I, j minus of s, j minus I minus of s, and j. So these are the two regions which we are talking about in this cell. Okay, So we will make 3. Okay, 3 as okay. We have 15 as a total sum, and then we will cancel out the 3 and 5, and also we will add the 1 because 1 is subtracting 2 times, that's why. And in this way, when we got any of the sum which is less than equal to the threshold, so we will return it as our answer. And if we haven't got any of the answer, so we will return it as a 0. Okay, so this is our whole solution. If you haven't got any of the concept, so you can comment down below and I will be clearing your doubts, obviously. Thank you for watching this video, and I will be see you in the next video. Thank you.